Okay. I guess sometime is left is free. Okay, so we're gonna give the today's LeetCode weekly contest, and let's see how much I solved. Like I expect Alien to for me to solving three problems at least. Fourth problem, like we cannot say certainly that I can solve. Since the fourth problem usually is a bit tough or it requires some good data structure, which am kind of not that much aware of good data structures like payment trees, etc. etc. And I don't even know sparse tables, these techniques. So I have to go through all of them, try to learn more things. I hope, really hope that I can solve three problems at least. Okay, get the point. So I got the fourth problem. Well, let's wait. Given an area of just nums, an array is ionic. If there is P index is PQ, okay, so that this is strictly increasing, strictly decreasing, and strictly increasing. Okay, we just brute force now. Constraints NQ. So internal solution NQ. So we find a brute force one another and then check in. Yeah. So in brute force, first of all, try to find out the array's length. Okay, constitution. Okay. I use P equals 1, P less than n minus 1, P plus plus. In Q equal P plus 1 and Q less than, I guess, n minus 1 again. And here it will be Q plus plus. So I got the Q and we will check whether it's increasing or not increasing. Checking for increasing and then decreasing. So check increasing. And bool check increasing vector of int ampersand nums and between L to R. So we'll have the return true as a form and we'll start I equal L plus 1 I less than R I plus plus if nums of I is less than equal nums of I minus 1 return false. So this is the code to check increasing and similarly to check decreasing. I just copy this to check decreasing. What to do? We need to check decreasing and this is what it will be. If it's greater than it's over. If it's great, we get that it should be decreasing greater than equal to. Okay, so it should be greater or equal. Written false. Yeah. So now we will write the snippet. If check int nums 0 0 p and what we do check deck nums pq and then check int nums p and minus 1 and in this case we will return the true that we found out that thing. Return false if this is not there. Okay, let come it up now. Yeah. So now this will be the solution, I guess. Brute force and Q accepts a wrong answer. What's wrong here? Wait. Increase, decrease, and increase, right? Oof. Uh, okay, stand debug it. See out. This thing, right? 3, 4. Okay, when it's 3, 4. This will be from Q, I guess. A simple typo. Submit. And Q should be get accepted, yes. And again, wrong answer. My goodness, what's happening here? Right. I'm not able to do any basic question. It just happens. 10 minutes from this easy question. Optimize beginning. Maximum trying sound. Okay, we can binary search for the maximum length says that it's trionic. So what is the condition for being trionic? Let's see. First, wait, it indicates a when passes straight line. Strictly less than the maximum. What is this? Weight representing the weights of n parcels in a straight line. A shipment is defined as a contiguous subarray of parcels. Shipment is the weight of the last parcel is strictly less than the maximum weight of one less than the okay. Contiguous balance shipments are the maximum number of balance shipments. Okay, binary search. And that's the answer is strictly less than so. Maybe number of this is zero, number of balance shipments is zero, and we'll try to do find a bigger answer. High in the worst case you can get n minus n. I guess I'm considering n. Go for bigger range also. It doesn't matter because we cannot get when you think wisely n means and each of them and we'll check, right? So we'll check for what. Okay. Okay. Yeah. Here binary search is also not required. I guess directly counting the things would do the job. I guess. Okay. We got outlets. Understand. Okay. Yeah. Maximum will be chance of the maximum is there. Okay. C equals zero. I thought of binary search initially. Let's do the ranges. And we can set maxi to 0 again and return the it. This is too slow, yeah. Nums right. Wait. Okay, going to be done with the second half. You can string length the permutation and you will orders the number of numbers in the range. Okay, we're given a permutation order. Okay, 0 to n minus 1. Frequency index and order S, order T with star at each time, each step. Okay. The various substring result will contains at least one hash string is active. Total number of various substrings is greater than equals to k. Minimum time. Okay. Minimum time. Minimum time. Oh, the substring is active. Okay, becomes this is loosely simple. And the end, if you do, it doesn't get active. So, what do we have indexes, right? Okay, they are already active. So, yeah, we use set index id access and auto post order. Okay, I'm just coming in 1 minute. నీళ్ళు ఎక్కడ చూడు ఎక్స్ట్రా ఒక బకెట్తో కొట్టాను ఎక్స్ట్రా చూసి సేఫ్టీ కోసం. What's to do the fourth problem? It should increase and then decrease and then increase. जब तक वो डिक्रीज कर रहा है we try to go, जब तक इंक्रीज कर रहा है we try to go. So that's what is the procedure. Okay, so we are still in the. This looks like some sort of dynamic programming. I used to give the standings just for us. I guess I'm doing decent enough. Okay, so here apply dynamic programming. DPF once means L to PF. L is P and its L should be greater than L. Okay, so basically we have found out an increasing. So at the end it should increase. We found out increasing. So I mean like what should happen actually is it should increase, decrease and then increase. So at the end we found increasing and then for the DP of 1 which we found increasing. The sum of the increasing and then once there is it should decrease. So it's increasing here and then once it decrease so it should decrease means I mean it has to be decreasing so yeah they should be greater than that. Hmm. Then we found out decreasing and if you else get the something same then you try to reset it. So we'll apply 3 DP. So DP of 5 comma 2 is we found increasing, we found decreasing as well, and we found again another increasing. And the answer is should be the problem should solve. Vector of vector of long we just get n in size int n equals to nums dot size and we need to just make sure that we don't find anything. So we'll give that negative 1e9 or somewhat like that. I guess the sum, yeah, the sum can go really huge. So 118, negative 118, or whatever, negative 1. So what we do is vector of long, and it will be a 3 since we need 3 states, and you can give into min, or you can just even give a negative 1e16 or 1e15. I guess why LeetCode has a really less limits. 1e18, let's go. Let's return the one. Let's see whether this actually works. In LeetCode, I don't know the limit of the integers. Let's go. If the negative 118 is 253. So 2 to the power 53, let's go. In LeetCode, this is the limit. It's around 1e15, so you can give 1e14. What should I give? 1e14, I guess. 14? Yeah, 1e14. Yeah, okay. Okay, n minus 1, I greater than equal 0, I minus 1 is we just now transitioning to the states. If uh if the first of all we need to know is if AI, so obviously we can define the base cases. We assume that is in the increasing slope. So dp of n comma n minus 1, this can be the base case. So we can kind of avoid everything out with the extra space here. And we begin with n minus 2 and try to make sure that it should be greater than, yeah, it cannot be 1. Because I guess can be 0, but what is the point? What I'm trying to say here is we found something. We found some increasing sequence and then some decreasing. That should have at least two errors. Yeah, that's exactly what I'm saying. So let's try to understand this a bit more clearly and try to solve the problem. I guess. Where's the one note? So what is happening here is uh, it should increase, decrease, increase. So we have to come up to this. So if it is increasing, then it's fine. So previously it should be increasing. That is what I'm trying. It cannot become increasing over here. Okay. So in the base case, it's we assume that it's increasing, and it's increasing. Then the sum is nums of n minus one. If AI, so it should decrease in order to maintain the increasing nature. If AI is less than AI plus one, or then dp of I comma 0 equal to dp of I plus 1 comma 0 plus nums of I minus 1. This is the nums of I. And considering, so it has increased. So 3 become less means it is in the increasing slope. So we found everything decreasing also. Uh, I plus 1 and not. And we have to kind of make sure that we just kind of don't overflow here. I guess I can use the 64-bit integer to kind of save down. Int 64. I guess it's for int 6040. How is it represented? Okay, int 6040. Yeah. So this will be int 6040, I guess. This should work for kind of preventing overflows. Plus nums of I, right? I guess this does not give any compiler. This is a mistake syntax. Let's go. Okay, fine. Everything is fine. Now let's just correct this nums. This is over fine. And else other things like if we were in the decreasing slope. So suppose this thing happened and we found out a decreasing slope. We were in an increasing slope, fine, and we found out a decreasing slope. So if it is less than that, then we are in the decreasing slope, right? Decreasing slope. Okay. So let's go size. This will be if A nums of n minus 2 nums of n minus 1, then there is a possibility that we can find the increasing slope. That's why I'm giving it the base case. Otherwise, it's not possible. Why it's not possible? And there are negative elements also, right? So we have to kind of find out the maximum sum, right? And the overframe time complex. Let's think about it. Because since there are negative elements. So if that num psi is positive, so if it is less, right, it's less than it. So if it was negative, then we could kind of ignore it. Since increasing in negative means that what I'm basically trying to say is let's understand with some example. So if this was a negative element, 10, -5, -4, this is increasing over here. So, but what is the thing you want to take here? You want to just take this thing, right? The smallest thing. If everything is negative in this. So if everything is negative, this is the maximum value. And if this is negative, then we will not take everything. We will only take these two things. Understanding this point makes you the thing. If this thing was positive, if it's at some point here increased. So if this was a positive, then there is possibility we will try to take everything. Because they are negative numbers, we have to take them in that scenario. And it has to kind of you cannot take direct increasing, right? Kind of it should be previously increasing. Else scenario, it has decreased. It has what decreased? Below this dp of I1 would what? What it will be? It's greater. So we found out the negative one. So dp of I comma 0 with num. So we found out the decreasing segment also increased up to some point. So it will be at least two elements in the increase and it decreased. So if you take PQ here and it should increase now. Else in the three of the scenarios, if I was a zero, it was equal, then continue doesn't have any significance. Else, what you going to do is DP. If it is same, if the nums I minus 1 is kind of less than nums I, what we do is we can give dp of I comma 0 as nums I. Fine, we can give it. Now in 60/40, answer would be kind of -1 is 16 I equals 0. I less than the answer would be max of answer comma dpo I comma 2 return answer. I guess this should solve it. Okay, so we'll understand. This should be greater than this. So here it will be what? 1. Yeah. Oh, it will be I plus 1 x. I got a 14. I got a. Okay, this is what I need to kind of improve. If you just look at this, no, you'll not have anything. And if you look at this, just you can also reset. Okay, we'll understand this test case to kind of, I guess, we are really close of solving. 2993. Okay, yeah, negatives case. Yeah, I actually told about this. Okay, again another wrong answer. Okay, so again, another answer. I guess I can use some VS Code. Let's try that. I got a negative 4. Oh my goodness, wait. Let's wait. This is a good problem. Let's wait. We can always reset at any point. We can reset. यहाँ पे देख, वो चीजें, ठीक है, अभी यहाँ पे इंक्रीज हो गया। I hope I finished out the entire contest now. It was a good experience. So I hope you guys really enjoyed it. I solved all the four problems within 1 hour, I guess. And this was pretty easy contest. The first three problems were kind of greedy, and the fourth problem was 3 2D or dynamic programming states, where I just messed out a bit, but still finally solved the problem. So this is a really good experience. I hope you guys enjoyed. Thank you.